Students, welcome back to Algebra 1B. Today we're going to be talking about solving quadratic equations by a technique called completing the square. So we've been building up to this bit by bit. We started off with problems that look like this. X squared equals 25, and we figured out that we could take the square root of each side, giving us x equals 5 or negative 5. From there, we went on to a squared binomial like x plus 1 squared equals 25. And in this case, we would square root both sides and get x plus 1 could equal 5, or x plus 1 could equal negative 5. And then we could subtract 1 on both sides, giving us the answer x could equal 4 or negative 6. Now, a small jump would be to do something like this. X squared plus 12x plus 36 is equal to 49. And that doesn't look anything like this one, except we're good students and we realize that this is a quadratic trinomial and this is something that I know how to factor. So I'm just going to go ahead and factor this. X squared, 36. I know this is x and x, and I need two numbers that multiply to 36, but they add up to 12. And that's pretty simple. That's 6 and 6. So I would get 6x and 6x. So I see that this is x plus 6 and x plus 6. Now, when these are both the same thing, it turns into x plus 6 squared is equal to 49. And now this is the same thing that we've been doing. I can take the square root of both sides. I'm going to move this up here so I have some more room. And I get x plus 6 could equal 7, or x plus 6 could equal negative 7. Let's just subtract 6 on both sides, x equals 1, or subtract 6 on both sides, x is equal to negative 13. Now, this is all well and good, but this only works if I factor something and it turns into a perfect square. So I want to sidetrack a little bit and do how to spot a perfect square. So now I've been an algebra teacher for a long time, so I can do these in my head, but there's a trick to it. So I'm going to write out a bunch of these trinomials and see if you can figure out the trick. How am I doing this in my head so quickly? So if I do x plus 3 squared, the answer is x squared plus 6x plus 9. If I do x plus 5 squared, the answer is x squared plus 10x plus 25. If I do x plus 9 squared, the answer is x squared plus 18x plus 81. If I do x minus 6 squared, the answer is x squared minus 12x plus 36. Now ask yourself, what's the pattern here? How come I'm not having to write out all my multiplication and I can do this in my head? Go ahead, pause it, look at it for a while, see if you can figure it out. Okay, so now that you've had a while to look at this, the thing that I'm hoping that you're noticing is that whatever number is in here, the b value right here is 2 times that number, and the c value is that number squared. So again, this one right here is a 5, this is 2 times 5, and this is 5 to the second power. Down here, this is negative 6 times 2, and this is negative 6 to the second power. Now, how do I use this to my advantage? Well, we can see that if I have a problem that's something like this, x squared plus 20x plus 100 is equal to 36. I can look at that and say, 10 times 2 is 20, and 10 squared is 100, so I know very quickly that this is x plus 10 squared equals 36. And I can square root it and get x plus 10 could equal 6, or x plus 10 could equal negative 6. We'll solve that real quick. Get x equals negative 4, or x equals negative 16. Now, that's nice as long as it just happens to be a perfect square. So, what if it isn't? What if I have a problem that looks like this? X squared plus 20x plus 99 is equal to 48. Now, I chose this one on purpose because it looks just like the last one that we did. So, in this case, if I were to try to factor x squared plus 20x plus 99, this would not end up being a perfect square. However, in order for it to be a perfect square, I wish that this 99 right here, I wish this were 100. If that 99 were 100, then the whole thing would be a perfect square and I could use my technique. This is where the technique comes in, called completing the square. Completing the square means that we are going to do something to the equation to make it turn into a perfect square. Now this one is pretty easy. I've got x squared plus 20x plus 99. What number do I wish this were right here? I wish this were 100. So, in order to make it 100, this is simple enough. I just need to add 1. Now, since we're good good algebra students, we know that if I add 1 to this side, I also need to add 1 to this side, which would give me x squared plus 20x plus 100 is equal to 49. And now I know x squared plus 20x plus 100 is x plus 10 squared is equal to 49. Let's solve that really quickly. X plus 10 could equal 7, or x plus 10 could equal negative 7. Subtracting 10 on both sides, we would get x equals negative 3, or x equals negative 17. Okay, let's go ahead and try a few more examples. Now, this one, I've got x squared plus 8x plus 19 is equal to 4. And at first glance, this one is not a perfect square. So I have to ask myself, what do I wish this were? Well, I'm going to go back to my formula right here. X squared plus bx plus c equals something. I know that I want it to turn into x plus something squared. Let's go ahead, we'll call this one d for a second. Now, I know that b is equal to d times 2, and c has to equal d to the second power. So if I look at this b value right here, I know that the number that I want d to be is 4. So I want this to turn into x plus 4 squared. Now, using my little trick, I know that x plus 4 squared is x squared plus 8x plus 16. So, looking back at my equation, x squared plus 8x plus 19, I wish this were a 16. Now, that's simple enough to solve. All I have to do to make that a 16 is subtract 3 on both sides, giving me, let me erase this to make some room for myself, x squared plus 8x plus 16 is equal to 1, which now I know this is going to turn into x plus 4 squared equals 1. Square root both sides, x plus 4 could equal 1, or x plus 4 could equal negative 1. We'll subtract 4 on both sides, and we'll get x equals -3 or x equals -5. Let's try that again. Okay, so x squared minus 14x minus 69 equals 3. So I wish this were, if I take this number right here, the -14, if I cut that in half, I would get -7. So I want this to be x minus 7 squared, which I know is going to be x squared minus 14x, and then -7 squared would be plus 49. So this one's a little bit trickier because what do I do to -69 to make it turn into positive 49? Well, the first thing I would have to do is add 69. Let me go off here, -69. I would add 69 to it to bring it up to 0, and then I would add another 49 on top of it to bring it to positive 49. So 69 plus 49 is 118. So let me erase this to give myself some room. I'm going to add 118 to both sides. So that would give me x squared minus 14x plus 49 is equal to 121. Oh, that's a nice number. And I'm just looking right there, and I immediately noticed that that's 11 squared. Okay, so x minus 7 squared equals 121. Let's take the square root of both sides. X minus 7 could be 11, or x minus 7 could be -11. We'll just add 7 to both sides. X equals 18, or add 7 to both sides. X equals -4. We're done. Now, all of this is good, but so far all of the problems that we've done have turned out with nice even numbers. So let's do something a little bit uglier. Now, this one, okay, x squared minus 11x, oh shoot. Here's a problem. What happens when I cut -11 in half? I want this to turn into x squared, I want this to turn into x minus 5.5 squared. Okay, so using my little trick, I'm not going to be able to do this one in my head as easily, but this is going to be x squared minus 11x plus whatever -5.5 squared is. So I'm going to use my calculator to figure this out. -5.5 in parentheses squared is equal to 30.25. Okay, so actually that's not too bad because all I have to do here is add 0.25 and it turns into 30.25. That's not a big deal. Let's do that to the other side as well. We'll add 0.25 over here. So now I get x squared minus 11x plus 30.25 is equal to 7.25. Now, the whole reason I did that was so this would factor into a nice perfect square. It's going to be x minus 5.5 squared equals 7.25. Now let's take the square root, and do you know what the square root of 7.25 is? I don't. Let's go ahead and use the calculator for that. Square root of 7.25 is equal to 2.692582. That is an irrational number. So for this homework, I'm just going to use the first 3 decimals. So I'm going to say x minus 5.5 could equal 2.69 and then round it up to 3. Or x minus 5.5 could equal -2.693. Now, let's finish that off. Let's add 5.5 to both sides. And then again, feel free to use a calculator at this point. 2.693 plus 5.5 is equal to 8.193. X equals 8.193. And now I have a calculator that I can edit here. So I'm going to cheat and just erase this and change that to a minus. Or X equals negative 2.807. We're done.